Dimensional analysis is about converting units, right? And most of what you're going to see in physics is complex units, right? Complex units are derived from the standard base units. The idea, if you can imagine 1 minute, right? It's almost easier to just demonstrate this with examples. 1 minute is how many seconds?
60.
60, right? This 1 minute equals 60 seconds is called a conversion factor, right? A conversion factor is something that is a true statement and can be written as a fraction equal to 1. And it's important to recognize that that fraction as 1 is proper whether or not it's upside down or right side up. In other words, this can be rewritten as 1 minute over 60 seconds. And depending on who you are, my S's look a lot like 5s. And so I tend to write out SEC whenever I think that it's necessary. But I will stop doing that and write S every once in a while. So if you get confused about what you're looking at, let me know, right? But develop a method so that you can tell the difference. I always write MIN for min because M is meters, right? So there's a bunch of different things that overlap. So you just got to pay attention. But this is the same as 60 seconds. Oh my gosh, this construction is going to drive me crazy. 60 seconds is 1 minute. It should make complete sense that that is true. That's what the equal sign means. Yes? Everybody comfortable with math? Perfect. So that means that if I multiply this times anything, it doesn't change the magnitude of whatever that object is, right? Whatever that measurement is. Because 60 seconds and 1 minute are the same thing, right? So if I'm given a base, or excuse me, a given that is more than 1 minute, right? 3 minutes. Most of you can logically tell me what the answer is without having to do any calculations. That's not the point, right? The point is to illustrate how we can get from 3 minutes to seconds utilizing the conversion factor. What? You know what 3 minutes is?
What? No, I
She was
do.
scratchy and it sounded weird. That's why I looked different.
180 seconds.
Very good. Very good. The format looks like this up here, picket fence, right? The idea is anything on top is a numerator, anything on the bottom is a denominator, and this is legitimately fractions multiplied across, right? So each one of these given spaces, or the picket, is a fraction. And what we're going to put in those fractions is this, conversion factors, because when we multiply times 1, it's not going to change anything about the starting value. And that's very important. We don't want to lose the information through the conversion. Make sense? All right. So I take my 3 minutes and I write my given. Now I have to write the whole word because I screwed up. I write the whole given as a fraction. 3 minutes over 1. That is the number 1. The reason why we do this is in part because it matches up to the structure of the given or the fence, but also because a lot of complex units, like I just showed you on the other screen, are fractions. And so there will be a term both in the top and in the bottom, right? Meters per second is the most common, and we'll go through that in just a second. But then, after I have my given, I bracket it off, and then I just think of this as an extension of more terms that are going to go out across. Right? In this particular example, we're only going to do it once, but the idea with picket fencing in dimensional analysis in this way is that I can do as many as I want. Right? I can go to minutes, I can go to hours, I can go to days, and so forth, all in the same string. Okay, so the only challenge is making sure that I utilize the factor of 1 correctly so that I get something that makes sense. And basically what I'm doing here is paying attention to the fact that in 3 minutes over 1, I'm multiplying by minutes, which means then when I multiply by 1, I have to have the minutes cancel and the seconds remain. Right? And so it's a matter of whether or not I'm choosing the format here, 1 minute over 60 seconds, or 60 seconds over 1 minute. Right? And it's very easy because if I want seconds to remain, I want minutes to cancel. So I put 1 minute on the bottom because I'm multiplying by minutes and then dividing by minutes. Those things will cancel out. And I'll be left with seconds on top. Then I just add in whatever that conversion factor is, which is 60 seconds in this case. I double check that as I multiply these fractions across, the minutes will cancel with the minutes, seconds will remain. I double check that this is what I want, and then I use my calculator, right? I do not go ahead and do any kind of calculations until I confirm that the labels have factored out. Factor label method. Make sense? We're double checking the words so that when I put the string into the calculator, I just trust that whatever the answer is done. And this makes sense for this easy one, but when you have multiple running across the page, you want to double check that everything has crossed out as you go across the page, and whatever you're looking for is the only thing left over. And that will be both in the numerator and the denominator, right? Changing from miles per hour to miles per minute, kilometers per second to miles per hour, and so forth. You with me? So then obviously all I have to do is think about this in order of operations from left to right, top to bottom. 3 minutes divided by 1 times 60 divided by 1, enter. That's how I want you to type it into your calculator. Right? If you do that, then you need no parentheses, you need nothing else. You just string it together in that thought. Left to right, top to bottom, enter. All in one string. So obviously we know that 3 times 60 is 180. 180 seconds is the answer. More realistic to physics, especially AP physics, is complex units like kilometers per hour, right? The base units for distance are meters, and the base units for time are seconds, which means that we are always going to be converting velocities or speeds into meters per second. So again, it's the same exact process. Setting it up as a fraction, putting in your conversion factors and working across. So if I say 40 kilometers per 1 hour, don't get hung up on thinking that I want to put this entire kilometers per hour in the numerator, right? Make sure you separate out the fact that 40 kilometers per hour really does mean 40 kilometers per 1 hour. It's not unusual, especially on an AP test, for them to throw something weird at you where it's like 40 kilometers every 2 hours, right? What you don't need to do is do 40 kilometers divided by 2 hours to find what it is in kilometers per hour and then do the work, because you can just put 40 kilometers per 2 hours into the calculation and you can skip that step, right? Part of the success on the AP test is efficiency, right? So save yourself as much time as possible. Now the neat thing about this is that operating on either one of these, you're still multiplying by 1. So you change nothing about what you're doing. So you can change the kilometers first or the hours first, because either way, you're just multiplying by 1 as you go across. And so it's really dealer's choice. But you just set this up with a bracket, and then we introduce a conversion factor that makes sense for at least one of the variables, right? And so let's operate on distance first, just because I picked it. How many kilometers, or excuse me, what is the conversion factor between kilometers and meters?
1,000 meters is 1 kilometer.
Good. Mara, is that what you were going to say? Good. It's also important to recognize that I can say 1,000 meters in 1 kilometer. I can also say, which happens if you look the conversion factors up on the internet, is that 0.001 kilometers is 1 meter, right? Because 1 divided by 1,000 is 0.001. So either one of those is effective. But I do not have any 0.00 stuff memorized, because it just doesn't fit in my brain that way. I think of everything as whole numbers. So when I relate meters to kilometers, I think 1,000. When I relate meters to millimeters, I'm still thinking 1,000, right? It's just easier for me. But if you go to the SI prefixes, if you look prefixes up, right, because you want to know how many exameters or how many meters are in an exameter, they're given in whole numbers for larger and decimals for smaller, right? So a lot of times you're going to get that millimeters, there is 0.01 millimeters in, or excuse me, 0.001 millimeters in a meter. But it's all, I mean, it's real, or excuse me, it's 0.001 meters in a millimeter. But I mean, we also know that there's 1,000 millimeters in a meter. So again, whatever you're comfortable with memorizing, you should know. It's also useful if you can do it in scientific notation and use the exponents. It's really up to you. And for most cases, you are not going to see these weird ones like exapeta and stuff. But because of computers today, you might, right? Exabytes is a thing, right? Networks process huge amounts of data. So exabytes and petabytes and terabytes and gigabytes and megabytes are very relevant in our culture right now. But also in science in general, nano is a big one, right? So -9 or 1 billion and so forth, as well as femto and atto. Those things are catching on because of the fact that there is a lot of small science going on. And so it's not necessarily that you need to memorize this list, but it is something that you need to be familiar with. Like, for example, micro uses the Greek letter mu as its symbol, right? Because M has already been utilized for a variety of different things on the page. So you just need to be aware of that. Generally, the ones that I have memorized, just because you should, is kilo, mega, and giga. And then down here, centi, milli, micro, and nano. 6 or 7 of those, right? The rest of them, that would be something that you would raise your hand and ask if you forget, right? But if you can memorize these things, it will make your life easier. All right, so nonetheless, back over here. If I want to use the meters, 1,000 meters per kilometer, right? It's already in this format set up the way I want it to be, because I want kilometers to cancel on the bottom, and I want meters to remain on top. Right? And so I'm double checking that this kilometers is going to cancel out and the meters is left over on top. Now, whether or not you're circling and drawing arrows and those kinds of things, obviously as you get better at this, you don't need to do that. I'm just doing that for emphasis. But the point here is that I don't have to stop and figure out what it is in meters per hour. I can instead just draw a new bracket and move on. Right? I'm comfortable that I'm done with M, done with meters. So now I'm going to operate on hours. I'm trying to get from hours to seconds in the denominator. And if I know how many seconds are in an hour, then I would utilize that factor because it would make it go faster. I don't have to do that, right? Because again, I can do this bracket as many times as I want. So for illustrative purposes, there are 60 minutes in 1 hour. Is that right? Look at the screen. Does that work for what I'm trying to do? No, it doesn't. Because when I multiply across, I'm going to get hours squared on the bottom and minutes on top. And then that's going to be meters times minutes divided by hours squared. And that just blew the whole thing up. It's wrong. Right? So this actually needs to be the other way around. 1 hour and 60 minutes. Make sense? Because now hours is divided in the first term and multiplied in the last term. That leaves minutes on the bottom. Minutes gets me closer to seconds, so then in the next step, obviously I want minutes on top and seconds on the bottom. And I know that in 1 minute there are 60 seconds. I find it helpful to think labels first and then put the numbers in, just so that it comes easier. But you can practice that as you go. So then minutes is divided, minute is multiplied, seconds remains on the bottom, seconds is what I want down here. And so now all I have to do is string this together, right? We're ignoring this one here in the middle. 40 divided by 1 times 1,000 divided by 1 times 1 divided by 60 times 1 divided by 60. Now obviously you wouldn't type in times 1 and divided by 1, but if you wanted to, you could, just to make sure that you're doing the process correctly. What I don't want, and this is more of a just general practice kind of thing, is for you to go 40,000 divided by 3,600. Right? Do not do that. Always start from the left, go from the top to the bottom, and work your way across. Right? There's reasons for that, but we're not going to get into it today. Does that make sense? Does anybody have any questions? So if I type in 40 times 1,000 divided by 3,600, what do I get? $11.111111 based on significance that we talked about is really what as an answer? 10. 40 has one significant digit, right? And so my answer is 10 meters per second. And that brings up what I forgot yesterday. Third rule. 60 seconds is a minute. That is called an exact value. Exact values have an infinite number of significant digits. In other words, if this had 4 significant digits, then your answer should have 4, despite the fact that it looks like everything else in the problem only has 1. Does that make sense? So the 1,000 meters in 1 kilometer does not limit your significance, because by definition, there is exactly 1,000 meters in 1 kilometer. That was the one tidbit on significance. Does anybody have any questions?